Have you ever seen an iceberg? You know those enormous chunks of ice floating in the ocean? These are essentially frozen seawater, and they're often far bigger than the ships that sail right by them. If you've seen one, you may have wondered what it would be like if the world was made out of nothing but ice. Ice is found all over our planet. It covers both of our poles and can also be found deep within the ground. But here at Earth's surface, most of it is water that's frozen because of the low temperatures. That is, after all, how we get ice cubes in our drinks. When water reaches its freezing point, typically around 0 degrees Celsius or 32 degrees Fahrenheit, it transforms into a solid state known as ice. This happens due to the unique molecular structure of water. The individual molecules slow down and form crystalline lattice held together by weak bonds. As more and more water molecules freeze, these bonds become stronger, creating a solid structure. But if ice is just frozen water, and we're made mostly of water, does that mean we could turn into ice? Well, there's some complexity to the answer. Your body is about 60% water, but the other 40% is pretty important. It contains things like fat cells, proteins, and minerals, which don't freeze like water does. However, the water in your body, if somehow separated from this other stuff, would behave like any other water. And therefore, if you were somehow magically un-you, then yes, you could indeed freeze into an ice cube. But the real question is whether anything could survive being frozen. At first glance, you might think no. After all, ice is hard. Take a bite of an ice cube, and you'll probably find that your teeth can easily break through it. And even if it didn't crunch, you'd still be left with a terrible brain freeze. So how could anything stay alive inside something so brittle? Well, ice isn't actually as hard as you might think. While an ice cube is easy to crunch because it's only hard in certain directions, ice in general is fairly isotropic, meaning its properties are roughly the same no matter which direction you approach it from. Ice is somewhere between 40 and 110 times harder than water, depending on the exact pressure and temperature. And while that sounds really strong, that means ice is less hard than something like granite, which is 100 to 150 times harder than water. In fact, ice is about as hard as bone. But wouldn't the expansion of water upon freezing cause the ice to crack? You've heard about how water expands when it freezes, but exactly how much does it expand? Water expands by about 9% when it turns into ice. This is because of the unusual hexagonal lattice structure of water molecules when frozen. Each molecule forms a strong bond with 6 others, which creates empty space between the molecules themselves. This phenomenon is responsible for the lower density of ice compared to water, which allows icebergs to float. However, the actual volume change during freezing depends on several factors, including impurities and the rate of freezing. For example, seawater freezes at a slightly lower temperature and doesn't expand as much, because the dissolved salts lower the freezing point and also hinder the formation of the open hexagonal lattice. Even small changes in temperature can affect the extent of expansion, which can play a role in the cracking of ice. If you're worried that these changes in volume will destroy your ice-based body, you can rest easy. Our bodies have evolved to withstand these changes without breaking apart. In fact, organisms living in icy environments have developed various adaptations to not just survive, but thrive in such conditions. For instance, certain fish species produce antifreeze proteins that lower the freezing point of the water in their bodies, preventing them from turning into popsicles. Other animals like turtles have evolved the ability to slow down their metabolism significantly when temperatures drop, entering a state called torpor to conserve energy and survive the winter. Even at the cellular level, organisms have adapted to icy conditions. Some bacteria produce special enzymes that function optimally at low temperatures, allowing them to carry out essential processes despite the cold. In terms of movement, we humans usually use our muscles to get around, but ice wouldn't be much good for walking. Luckily for us, we've evolved to move in ways that ice can accommodate. We'd slide around on our bellies, maybe taking the occasional tumble. Plants, too, have found ways to adapt to icy conditions. Some Arctic plants have developed shallow root systems to absorb nutrients from the thin layer of soil that thaws during the brief growing season. Others have hairy stems and leaves to trap air and provide insulation against the cold. These adaptations allow them to not only survive, but also reproduce and grow in challenging environments. But how about weather? Would it snow, rain, or hail in an ice-based world? The type of precipitation we experience depends on the temperature of the air and the amount of water vapor present. Snow forms when water vapor in the atmosphere condenses into ice crystals, which then fall to the ground. This typically occurs when temperatures are well below freezing. Hail, on the other hand, forms when strong updrafts in a thunderstorm carry water droplets high into the atmosphere where they freeze and then fall to the ground. The size of hailstones depends on the strength of the updrafts and the duration of time the stones spend in the clouds. So if everything was made of ice, would it rain, snow, or hail? The answer is, technically, anything could happen. Hailstorms would certainly be possible, as would blizzards. There could even be ice-based rain. But let's be honest, if everything was made of ice, we probably couldn't survive long enough to experience the weather anyway. You see, the thing about ice is that while it's solid, it can only exist under specific temperature conditions. Above a certain temperature, the ice melts into water. Below a certain temperature, it becomes so hard that it behaves like a glass rather than a true solid. And since our bodies are largely made up of water, it stands to reason that if everything was made of ice, the range of temperatures in which life as we know it could exist would be incredibly narrow. What's more, ice is not very good at insulating. If our entire world was covered in ice, heat from the core would eventually radiate away into space, causing the entire planet to become a giant snowball. Some people believe that Earth was once covered in ice, and there's evidence to support this theory. The so-called cap event, or the cryogenian period, is believed to have occurred between 720 and 630 million years ago. During this time, Earth's average surface temperature is estimated to have been as low as -20 degrees Celsius or -4 degrees Fahrenheit. Evidence for this ice age comes from various sources, including ancient glacial deposits, chemical signatures in rocks, and fossils of organisms adapted to cold environments. Some researchers suggest that volcanic activity released methane and carbon dioxide, which led to a greenhouse effect and eventually caused the ice to melt. Others propose that the breakup of supercontinents increased ocean circulation, allowing heat to be distributed more evenly and melting the ice. Regardless of the cause, the melting of this ancient ice sheet had profound effects on Earth's history, shaping the planet's climate and making way for the evolution of more complex life. Now check out what would happen if every human turned into a zombie. Or watch this video instead